The last part of this chapter involves solid ionic compounds that dissociate when put in water. Dissociate means that these solid compounds break up into their ions. And a couple quick tips to remember from review from last year: if there is a subscript down here, that means that you're going to form more than one of those ions. Also, another thing to remember is that our polyatomic ions don't dissociate. So like this sulfate compound here would be kept as one ion, or ammonia would be kept as another ion. What we're going to practice here will help you when you work on your solubility product problems, the KSP worksheet that's in Moodle. There's also a video that goes into the KSP problems. So what we want to work on here is just how to break up ions, solid into their ions. What we can see in A, in our first compound here, is that this potassium sulfate here, when it dissociates, breaks up into 2 sodium ions and 1 sulfate ion. So when setting up an ice table, at equilibrium, we would have twice as much of our potassium ion as we do of our sulfate ion. Because initially we'd start out with 0, the change in this case would be plus 2x, and the change in this would just be plus x. So this will come into play when we solve our soluble, our KSP problems. The next ion here is calcium chloride. Calcium chloride breaks up into calcium ions, which are 2 plus, and 2 chloride ions. Remember that you might need to look at the periodic table in case you don't remember the charge of these ions. This next problem here, iron, we figure out what iron's charge is from doing the reverse crisscross. We have 1 iron ion that has a 3 plus charge, and we have 3 nitrate ions. This next one here, ammonium, is a positive polyatomic ion, and that results also in 1 chloride ion. The last one here is silver. Silver, again, has a plus because there's that subscript. We have 2 of them, and then we form 1 carbonate ion. The last thing to go over here, again, just to remind you, when we set up our ice tables, we look at the coefficients in front of our ions. That'll tell us our change. We'll use that when we know to find our equilibrium concentration in the ice tables.